Hey everybody, welcome to activity 8.3. How much chemical energy is there? And our learning target for this activity is we're going to investigate what influences the amount of chemical energy that is transformed into thermal energy. And when we start talking about chemical energy, well, remember, energy stored into bonds of chemical compounds. That's basically what chemical energy is. And chemical energy may be released during a chemical reaction. Often it's in the form of heat. Such reactions are called exothermic. Reactions that require an input of heat to proceed may store some of that energy as chemical energy in newly formed bonds. So, what I want you to do first, before I get into what we're going to do today, is I want you to make a prediction. What factors do you think will influence the amount of chemical energy being transformed during chemical reactions? For example, in activity 8.1, how could you make the temperature of the solution increase more? So, go ahead and make a prediction. And while you're doing that, just pause the video. All right, so you've had a chance to make a prediction, and I'm hoping you made a prediction. If you didn't make a prediction, you're not going to get credit for this activity. I know I've had some students say, well, I don't know. How am I supposed to know? It's just a prediction. What factors do you think will influence the amount? So think back to the factors that influence GE, KE, EE, and use your thinking cap. What factors do you think might influence the amount of CE, chemical energy? All right, so this is what we're going to do in this lesson, in this experiment. This video actually, or activity 8.3, and this is a video too, we're actually going to do two mini experiments. So in the first one, if you look at this, it kind of looks a lot like what we did before. Now the learning target for the first one is we're going to investigate the influence of mass of a substance and what kind of impact it has in the amount of chemical energy a substance has. So it looks just like what we did before. In the video that you're about to watch, you're going to see me mixing 5 grams of copper chloride with 50 milliliters water. I'm going to stir it up. I'm going to record the temperature. Now, when you see me recording the temperature, make sure you're listening because I'm not going to put it on the screen, but you're going to have to listen to me tell you what that temperature is, and you're going to record it right here. Then what I'm going to do is I'm going to mix in 0.8 grams of aluminum foil. So this is where it's different. In experiment 8.1, I put in 0.5 grams of aluminum foil. So what changed? Well, the mass changed, which is why, how is mass going to influence the amount of chemical energy? So again, watch the video. In the end, listen to the video. I'm going to tell you what the temperature change was. And again, you're going to have to put that right here. Then take this number minus this number. Actually, it's this number minus this number to get this number. And that will be your temperature change. Now, while this whole thing is happening, make sure you type in here, what did you observe happen in the mixture? So go ahead, pause this video, watch the activity 8.3 video that should be titled activity 8.3, 0.8 grams of cupric chloride, or 5 grams of cupric chloride with 0.8 grams of aluminum. So it'll probably be actually titled activity 8.3, aluminum foil, 0.8 grams. When you get done with the video and you get done recording your observations, go ahead and start the video up again. All right, so now that you've recorded your data and you recorded what happened in number 2, go ahead and answer the next question, please. So when you look at those questions, number 3, is the thermal energy of the mixture larger or smaller after putting in a bigger piece of aluminum foil? For activity 8.3, 0.8 grams as compared to activity 8.1, 0.5 grams. So if you need to go back to activity 8.1 to look and see what the temperature change, go ahead and do that. Now, while you're doing that, you can go ahead and pause the video. Now for the third question, well, that was the third question. Now for the fourth question, if there was more thermal energy when more aluminum was added, where does the additional thermal energy come from? If there was not more thermal energy with more aluminum, where did the thermal energy, or why did the thermal energy not change? So go ahead and answer question 4. So if you're going to pause and wait for me to show you the answers, I'm not going to show you those. You need to answer these questions on your own. So go ahead, pause the video if you haven't yet, and answer questions 3 and 4. All right. So what you actually saw happening, you actually saw the copper chloride and aluminum, and due to the chemical reaction, the elements are the same, the amounts are the same, as they just got shifted around. So what you came out with was copper and aluminum dichloride. And here's the balance equation that you see. So we went from one to the other, and this is your balanced equation, so everything balances out. So now for experiment 2. So in experiment 2, the learning target is we're going to investigate whether the type of substance influences the amount of chemical energy a substance has. So again, this is going to look almost the same, except now, did you notice we're back to 0.5 grams, just like in 8.1, we use 0.5 grams, but now we're going to use steel wool. So again, go back to the learning target. We're going to investigate whether the type of substance. So when we switch from aluminum foil to steel wool, will this impact the temperature that we get in the end? Does it influence the amount of chemical energy a substance has? So what I want you to do is I want you to watch the video. Again, it's going to be titled something like Activity 8.3, except now instead of 0.8 grams of aluminum, it'll probably be titled Activity 8.3, 0.5 grams of steel wool. Go ahead, watch the videos, make sure you listen to the videos, you record the beginning temperature, the after temperature, and get the temperature difference, and make sure you're typing in your observations. So go ahead, pause the video. All right, so now that you paused the video, I want you to, and you wrote down your description, go ahead and answer question 7. Is the thermal energy of the mixture larger or smaller after putting steel wool in with the copper chloride as compared to the same mass of aluminum foil? And again, if you need to look back at activity 8.1, please do so. So go ahead, pause the video, and answer question 7. Now you got one more question to go. Question 8. Why did the thermal energy of the mixture increase less when you put steel wool instead of aluminum foil into the solution, even though they had the same mass of 0.5 grams? So go ahead for number 8. What do you think is the answer to that question? Pause the video if you need more time. All right, so in the second part of this, again, you started with cupric chloride, except now, instead of having aluminum, you had iron. That's your steel wool. And when we put those together, they actually did a little mixing up, where now you left with copper and iron dichloride. And remember, di meaning 2. That's why it's dichloride, 2 chlorine. And here's your balanced equation for that. So again, what happened? What did you notice? Once you've had a chance to think about that, go ahead and answer the 2 making sense questions. What factors determine the amount of chemical energy an object has? And give an example of chemical energy in your daily life. Explain how you know it is actually chemical energy that you are using. So go ahead, pause the video, and answer questions 1 and 2, and then we'll come back together in a few minutes. Bye. All right, in the second part of this, what I'd like you to do is take a look and see how you did. So what were your observations? Did you talk about the color of the solution and how it changed? It went from a pretty blue color to like a murky, almost milky looking, rusty color. It's hard to even describe. The new substance that you got was copper. Maybe you mentioned that a gas was given off. And remember, whenever you have gases, make sure you waft it towards yourself. Don't just take a deep breath. Did you hear any sizzling, any crackling? Did you feel the outside of the beaker? It should have gotten a lot warmer. You should have noticed a huge temperature change here. Then for 7, is the thermal energy of the mixture larger or smaller after putting steel wool into it. So here, let me go back. We're actually in question 3 right now. So is the thermal energy of the mixture larger or smaller after putting in a bigger piece of aluminum foil? Well, you should have noticed that the temperature changed more. That the temperature change for the 0.8 grams of aluminum foil was a change of 44 degrees approximately. Now your answer is going to be different based on the video that you heard this year. This was based on actual evidence from another time ago. So your numbers will be different. Don't copy these down. Use the ones that you saw in the video. So the first time I did it, I got a 44 degree temperature change versus a 30 degree temperature change. Again, use your data, not this data. So you notice that there was a much larger temperature change. So it seems like if you add more aluminum foil, there is a greater temperature change. So if there was more thermal energy when the aluminum was added, where does this additional thermal energy come from? Well, it came from the increasing amount of aluminum foil, 0.8 grams versus 0.5 grams. So this tells us that one of the factors that influence the amount of chemical energy is the amount of material that's used. So the material this time was aluminum foil. I changed the amount. I added more aluminum foil. It had a bigger temperature change. So now in the second one, again, take data. You should have data from the video. So what did you observe here? Again, there should have been a color change. You know, a blue to almost a greenish looking color. It looked a little different than the aluminum foil. The steel wool color changed. New substances appeared. It was rusty looking. It was copper, and the reading of the thermometer increased a few degrees. You should have noticed that the temperature change was not nearly as much. If you felt the outside of the beaker, not nearly as much. You really couldn't hear much for crackling. Every once in a while you can hear, but the temperature change, the type of reaction was not as violent. It was not as great as with the aluminum foil. So when we look at this next question, is the thermal energy of the mixture larger or smaller after putting steel wool, again, 0.5 grams versus the 0.5 grams of aluminum foil? Well, folks, the steel wool, 0.5 grams, was much, much smaller. It only changed like 4 degrees Celsius. Again, make sure when you take this data, you use your data from the video. Don't just copy this down. Now, when you compare that to the 30-degree temperature change of the 0.5 grams of aluminum foil, again, you use your data from 8.1. You saw it was a much, much lower, smaller change. So if it was so much smaller, why? Well, the thermal energy for the steel wool mixture was smaller because different substances, steel wool versus aluminum foil, contain different amounts of potential chemical energy to convert into thermal energy. So when we go back and we start talking about the factors, the type of substance influences the amount of chemical energy there is. So it's the amount, the mass, and then the type of substance. So let's look at these last two making sense questions. What factors determine the amount of chemical energy an object has? Well, the mass and the type of substance influence the amount of chemical energy the substance has, which is transformed into chemical reactions. So again, mass and type of substance. And then finally, give an example of chemical energy in your daily life. People get chemical energy from foods. Chemical energy is in gasoline used to power cars. The chemical energy in batteries to power your phones. So chemical energy is all around us. So as always, if you have any questions about this lab, make sure you ask your teacher. So don't go away thinking that, oh, I don't need to know this. I don't care to know this. You're going to want to know it for the test. So as always, thanks and see ya.